If these types of questions are giving you trouble on the SAT, we've got you covered. In this video, we're going to go over a 4-step process to simplify area and volume questions on the SAT.
The cool thing is the first 2 steps are going to be optional some of the time. And this first question will talk about all 4 steps, but we're going to not actually use step 1, which is to look up any related formulas on your cheat sheet. When I talk about the cheat sheet, I'm talking about that reference sheet that is available on the Blue Book interface. So for this question, step 1 is not going to be applicable because it's asking about the perimeter of the rectangle, and the cheat sheet does not include the formula for perimeter of a rectangle. That said, that is one that you should really know. The perimeter of anything is the outside of that shape. Basically, it's all of the sides added together. I suppose if you needed a little bit of help from the cheat sheet, you could see that there's going to be 2 lengths and 2 widths on a rectangle that match each other. So we could move on to step 2, which is to illustrate. You're going to want to illustrate any shapes involved and label them. So here we've got this rectangle. It says that we've got a length of 13 and a width of 6. So I've labeled that as well. And we just need to remember that these are doubled. So the right side is also going to be 6. The top is also going to be 13. And step 3 is to write down any formula or formulas that are applicable to the question. In this case, we could think of perimeter as 2L plus 2W, or we could just think of it as all the sides added together. The second part of step 3, after you write down the formulas, is to fill in the blanks. So in this case, our blanks would be L and W. We know that L is 13, so it would become P equals 2 times 13. We know that W is 6 plus 2 times 6. And then our final step, step 4, is to isolate the target variable. The target variable being the unknown that we're supposed to solve for. Here we know we're solving for perimeter, which is P, so we've already got it isolated, and then we just need to simplify the right side. So P equals 26 plus 12. 26 and 12 is 38, so our answer is C, 38. Make sure to pause the video, try this one on your own first using those steps we just talked about, but here we go. In this case, we get to skip step 1 because it's actually giving us the volume formula here, and the volume of a glass is certainly not on the cheat sheet, so that would not have helped us out anyway. Step 2 is to illustrate. Again, we get to skip this one. They already gave us an illustration. So we get to go straight to step 3, which is writing down the formula, filling in the blanks. And technically, we only have to do the second part of step 3 because they've already written down the formula. So we just have to fill in the blanks. So what are our blanks here? Well, it says volume is 473. So we're going to change volume to 473. And I'm sticking with that number because it says what is the value of K in centimeters. So we're sticking with the centimeter volume as well. And then we write the rest of this, 7 pi K third divided by 48. All right. And then from here, step 4, if you remember, is to isolate the target variable. It is asking what is the value of K, so we want to isolate K. So the steps I would take, multiply by 48 to get rid of the denominator on the right side, get 22,704. And yeah, I plugged that into my calculator. Okay, from here, we want to get rid of the 7 pi. So I'm going to go ahead and divide by 7 pi. We got 1032.42. And I'm just rounding up to the nearest hundredths place there. Now that's equal to K to the 3rd power. So then the last thing we need to do is get rid of that to the 3rd power, which means we're going to cube root both sides, and definitely use Desmos for this. A little extra tip here, if you can avoid using the keypad, get used to using shortcuts. If you type in CBRT, you get a cube root, right? All right, and then we get 10.11. And it looks like 10.11 is hanging out right there. So our answer is D. And moving on to a hard question. Again, pause the video, try this on your own first using the 4 steps. If you need all 4 of them, let's go through it. So, step 1, find the formula you need on the cheat sheet. The volume of a right circular cylinder is 22 cubic meters. As you can see here, they are not giving us the formula we need. So jump over to our cheat sheet, and it looks like the volume of a circular cylinder is going to be pi r squared times height, which makes sense if you think about it. Basically, you have a circle, and then that circle grows vertically. Step 2, we are going to go ahead and draw the shapes if we think it's going to be helpful. Just for the sake of best practices here, I will go ahead and draw this. So right circular cylinder A, we're going to say is this here. And then it's also saying, what if we have a right circular cylinder with twice the radius and half the height? So I'm just going to draw a much shorter and fatter one over here. Doesn't have to be beautiful, guys. And then let's label it. All we know is that the first one here is 22 cubic centimeters, and that's the area. Okay, step 3, write down the formulas involved. So we said that volume is going to equal pi r squared times height, and then we want to fill in the blanks. In this case, whoops, sorry, I wrote area instead of volume here. That should be a V, not an A. Please do forgive me. So we're going to fill in the blank. We know that V is 22, so we'll write that formula and we'll change to 22. All right, so what do we do from here? Well, it's an interesting situation because normally we would go to step 4, which is to isolate the target variable. Now, the target variable here is going to be for volume, but we already know volume. We're being asked about volume of this other hypothetical circular cylinder. So what is our target variable? We don't necessarily know, but what we do know is the volume, and we know that different combinations of radius and height can end up equaling this volume, right? So at this point, you can really just kind of choose your own numbers because we're going to be comparing this circular cylinder to the other one after we manipulate the height and the radius. At the end of the day, we actually don't even need to worry about pi r squared times height adding up to 22. We just have to figure out what happens to the overall volume of a right circular cylinder if we double the radius and cut the height in half. So let's just throw in whatever numbers we want and do that experiment really quick. Best to avoid the numbers 0 and 1. You might run into some problems, but let's just say that r equals 2, and let's say that h equals 4, right? So what would the actual volume of something like that be? So if we plug those numbers in, we get pi times 2 squared times 4. 2 squared is 4, so then 4 times 4 is 16, and then we end up with 16 pi. So that would be 16 pi. Now what happens if we double the radius? So now we have pi times 4 squared, cut the volume in half, times 2. Well, 4 squared is 16. 16 times 2 is 32, so we get 32 pi. So what happens? The volume doubles. And for that reason, we know our answer is going to be 44 because the volume of this purple one would double, meaning the volume of this shorter, fatter one would be 44. So that one was definitely a bit of an oddball. And when it comes down to it, you're going to want to go through these 4 steps, but just keep in mind with these more challenging questions, you might need to get a little bit creative.
If you're looking for more practice, you can use the link in the description to sign up for a free proctored practice exam. For more insights on improving your math score, check out this video for 5 tips that you can start using today.